So very good afternoon to all of you and welcome to this today's session on application of UAV remote sensing for disaster response. Right, so this is one of the very upcoming field of technology where drones have been effectively used in the disaster management uh, cases or disaster situations. How and what advantages they have, some few examples I will try to showcase in this in this talk of mine today, right? So, as you all have been listening about remote sensing, so you know that remote sensing is basically refers to capturing of information at a distance, that is remotely, by specific instrument called sensors. Traditionally, remote sensing has been associated with satellites or manned aircrafts with a set of sensors on board these platforms. Now, each of these platforms, whether we talk about satellites or aircrafts, have their own advantages. Like, for example, if I talk about satellite remote sensing or satellites as a platform, they provide a synoptic coverage with spectral range of spectral capabilities. But one of the major drawback is the resolution. That is, you have up to 30 centimeters, but then the cost is very, very high. When you buy 30 centimeter data, the cost becomes it's quite huge. And the temporal frequency of the data, which is bi-weekly or weekly, so one doesn't get the data when needed, so which is required in disasters because you do not know when a disaster would occur. So you do not get the data when needed. And in contrast to this, aircrafts provide a very high spatial resolution, maybe a few centimeters, but are very, very expensive for operations and are susceptible to weather and cloud conditions. Both satellite is also susceptible to cloud conditions if we talk about the optical data sets. But if we move on to the microwave data sets, they are, not affected by the weather conditions. So aircrafts, though, provide you high resolution, they have the cost is high and they are manned missions. So you have, because of this, the cost increases and the operations are susceptible to weather conditions. They are affected by cloud. Now, in contrast to this, there is another platform, which is the ground-based platforms, which provides you very, very high resolution information, but they are limited with the spatial extent. That means you can't cover a larger area. The coverage is very, very less, but they give you very high resolution, excellent positional accuracy, right? But the major utility of these ground-based platforms or instrumentation is for the calibration and validation of both aircraft as well as satellite-based observations, because you can't have a wide coverage. You have only point coverages. So in this, they have been generally utilized for calibrating and validating the satellite or the aircraft-based observations. Now, drones in the last few decades, drones have played a major, they have been evolved. So they lie somewhere in between the satellite and the aircraft and the ground observations, between the satellite aircraft and the ground-based observations. They are the low-cost version of the, you can say, airborne data, and they provide you a very good high-resolution data sets up to centimeter level. Then, since they fly at a lower altitude, they are unaffected by clouds. They can fly below the clouds, so you can collect data even on bad weathers, and they are cost effective and safe because they are not manned mission. So you don't, the cost of the manpower is reduced in this case. But the problems with these drone data sets is you can't cover a larger areas. You have, because the flights, we'll talk about what is the issues with these drone data sets, why they cover a smaller area, because they are lightweight. The battery power, energy is less in them. So they cover a small areas. They are affected or restricted by drone regulations, flying, but they are susceptible to heavy wind conditions, temperature conditions. If they are very hot, very cold, so they are affected by these instrumentations get affected. So in a nutshell, we can say drones play a complementary or a supplementary role especially for certain applications. And like major application in that is the disaster management. Why? Because in disaster, time is the crucial thing. The information has to be obtained and disseminated as quickly as possible, right? So satellites don't have a pass. Suppose there is a disaster in a certain area, earthquake has struck, floods are there, and you do not have a satellite pass on that day. How do I collect the data for any rescue or mitigation operations? How do I do mitigation measures? What do I do? So drones can be effective in those conditions, that immediately you can plan and fly drone, collect the data. So it comes into handy then. Another example where drones play a very important role is in terms of hilly terrain, mountainous areas. Where in mountainous areas you have is the issues are the shadows, the areas which are on steep slopes. They are not acquired by the satellite because of their acquisition geometry, their platform geometry, as well as the solar elevation angle. So they are collected at a particular particular time of the day. So sun elevation has a big role to play. Certain areas may be in shadow at that time. So radars also have a data. I mean, in case of microwave also, due to layover and shadow foreshortening, few areas are likely to be missed out in satellite observations, whether you're talking about optical or SAR. So in mountainous region, you have at least 15 to 20% of any study area of your hill region. The data sets is not collected up properly because of these issues. So drones can be used to fulfill this major gaps in the data sets. So they offer high versatility and flexibility as compared to the airborne systems or satellites, and operate rapid, and they can be operated anytime without any planned scheduling. So that is flexibility of operations. You can fly everywhere and every time. Flexibility to install any kind of sensors. The only thing is the weight of the sensors is the matter of otherwise, you can plan as per your requirement. If you can develop a sensor, you can install that sensors on the drone, then reduce the cost as compared to the other approaches, right? And they are unaffected by clouds, as they can, as I said, they can fly below the cloud cover, right? They can fly at low altitudes, collect images with a resolution of 1 centimeters, right? But as I said, the main issues are they can collect data over relatively smaller area, and their usage is governed by the regulations, drone regulations of the country. So the drones are basically, they fill the gap when very high resolution data is insufficient or is not available from a satellite platform, and airbornes are expensive. So they give you spatial as well as temporal frequency, high spatial and high temporal frequency. When you want the data at very frequent intervals, you can plan and collect the data at those intervals, right? So we've been discussing the advantages. They are lightweight, low cost, high spatial, temporal, fly at variable altitudes, autonomous flight because no manpower is required, only just to operate from the ground. They can move, you be deployed into high risk situations where humans cannot, reach inaccessible areas, and the data is immediately available. Once the flight is, you have flown the flight, the drone is brought back to the ground and the data is available. Challenges again are there are limited flight time, depending, you have some drones can fly only for 20 minutes, some 30, 40, maximum to 1 hour. So based on that, you cannot have a larger area coverage. So limited again by the camera weight. So sensors are, depending on the weight of the cameras, you can install those sensors only. Then regulations of the country, they are affected by the speed of the wind and gusts, though there are various versions of drones which are more stable, more robust to these atmospheric weather conditions, but then the cost of those drones are on higher sides. Then because of the low cost sensors, sometimes the quality of the data may be impacted, sometimes, but nowadays many good quality, low weight sensors have been developed, right? And you have a smaller footprint. Now, the drones, if I say so, are categorized based on their performances. Categorized by their performance different categories of drones or classifications of drones are there. So they can be based on the features including like the weight, the wingspan, the wing loading, the range, the maximum altitude, speed, endurance, production cost. These are various factors on which the different classifications of drones are there. But in India, we consider the three major categories: weight, size, range, and aerodynamics, right? So as per the Directorate of Civil Aviation, they have come up with the 5 categories of drones depending on the weight. That is the nano, micro, mini, small, and the large category. So the nano category drone is basically less than 250 grams. That is a maximum takeoff weight. The weight of this drone along with the sensor and all will be 250 grams. So it carries very, very small cameras, maybe just a picture. So these drones are generally used for hobbying or collecting pictures if required. And to fly these drones, you don't require much of a permission, because they have, even any damage or anything happens, it will not affect any human lives. Micro drones onwards, permission to fly is required. And generally on drones from micro onwards, remote sensing sensors can be placed, like an RGB or a multispectral sensors, which come in these categories. And generally mini are the ones which is more useful for the remote sensing applications, where you can have thermal and the other kind of sensors placed on that. Then the other feature on which the drones are classified is the range. That is, again, it is all are interlinked: close range, short range, medium range. So basically this depends on the weight of the drone. The weight is light, the battery power is, you have a very lightweight battery, and it cannot fly for a longer duration. So the range, it cannot go beyond the line, very long range. It will be at a shorter distances, very small areas near you, few meters around you will be the coverage area. Short range, that is 10 to 30 kilometers. Then short range is 30 to 70 kilometers. Again, this will be slightly heavier weight drones, where the battery power will be better than the previous one. So the weight will increase. So that is the flight time, which is known as endurance, would be higher than the previous one. Previous will be a 10-minute flight. So this may be maximum 20 minutes flight. So medium range is up to 200 kilometers. Then beyond that, medium range 2, which is there, or we can say far range, that is beyond 200 kilometers. Then based on the aerodynamics, we have fixed wing and the multi-rotor. Now, fixed wings looks like a normal aircraft which you fly, which you on board, which you go to different places, like an aeroplane. And the multi-rotor is like more of a helicopter, which has a multiple rotors here, which helps it to fly. Now this, in this case, the advantages of both the fixed wing and the multi-rotor, they have their own applications. They have their own advantages and disadvantages. So multi-rotor is basically, like, as I said, closer to an helicopter. It is easier to operate, cheap. It can go, doesn't require a landing and a takeoff space. So it can go vertical up and vertical down. So vertical takeoff and vertical landing, but it has a shorter endurance. That is short flights, 30 minutes max to 40 minutes. They have a low coverage areas, and they are suitable for mapping a smaller area. That because of the lower endurance, short flight time, they can cover smaller areas. Whereas a fixed wing, they need a specialized operators. But nowadays with even fixed wings, you don't need much. You can operate, but then they are relatively expensive than the multi-rotor, because and they require a sufficient space for a takeoff and landing. They have a longer endurance, so they can go up to 1 hour or so, and you require a specific permission also to fly these fixed wings. And they are, as I said, when they can fly at larger areas, longer distances or longer time, then larger areas can be covered. So fixed wing is basically best suited when an extended flight time or a larger area coverage is required. If you have to map in a very undulating terrain, mountainous, hilly terrain, small areas are to be mapped, then these multi-rotors are more suitable. And multi-rotor also has an advantage that they can stay stationary at one point for a sufficient amount of time. So in a rugged environment, in where you do not have sufficient space, small areas to be covered, you want to have a flexible flight. Like if you want to cover along a building, the damage has happened in a building. So along the entire building, you want to go a circle around the building, so it can be tilted. So rotors can be coverage. The angles can be rotated also in a multi-rotor. Fixed wing goes just like another view, like an aircraft. So wherever flexible flying is required, then rotors are more advantageous, right? So these are the few pictures of these there. So you have, various categories of single rotors, like you have only one axle. Then fixed wings, hybrid is there, which is now been developed, where instead of requiring a taking off landing space like an aircraft, you can do a vertical takeoff and landing, or you can launch them by hand. So they look like this is a model which looks like a fixed wing but operates for takeoff and landing like a multi-rotor. You can launch it by hand and bring it down by hand itself. Now solar powered drones are there. So different categories of drone. The cost and other features vary. So depending on your application, one can choose the kind of drone which is required. So if you talk about drones, so there are, the different components of a drone. The drone, basically, this is the base unit, whether it is a fixed wing or a rotor. So depending on that, you have a base unit. Then you have a GPS and an IMU module. The GPS is basically required to navigate the drone. So the drone has a communication with the ground station. You tell them where to fly. So this makes navigates the drone where to move and how to collect, where all to collect the data set. So pathway defining, right? Then you have a flight control system, which is the heart of the drone itself, which is contains also a gyro stabilizer, which is basically to give the drone its smooth flight capabilities. So it works almost instantly to the forces moving against the drone, keeping it flying or hovering or moving very smoothly. So basically, they provide the essential navigational information to the flight controller. So these are the gyroscopes, which are also part of the drones itself. So which is there. And then you have also along with this, you have a ground control station or a ground controller, station controller, which is also, it can also be a smartphone app, which allows you to fly drone and keep the track of the current flight telemetry, where all it is flying. So you can define a path, waypoints, where all the drones will fly, and continuously monitor using these smartphone app or a ground control station, right? So it shows you how the drone is moving, where all it is collecting the data. So what parameters it has the UAV range, height, speed, the GPS strength on board it, and then how much battery power is remaining. So it gives you warning that battery power is dying out, you can bring it back to the ground. Okay. Then you also have a live video transmission in some of the drones technology. You have facility for live video transmission to the ground control station. Then you also have a battery here, which is used to give energy to the drones, and then you have a gimbal and the sensor which is there. So on board the gimbal, you have a stabilized sensor, remains more stabilized. So gimbal is basically to give stabilization to the sensor so that the movement does not affect the picture quality. So these are the major components of the drone. Then you also have, sensors. Many kind of sensors can be, large range of sensors can be equipped with the drones and cameras. So you can have an electro-optical sensors, which is referred to as simple cameras, optical cameras. They can give you still images or video images. It kind of depends on the megapixels which you have purchased. Then the forward-looking infrared cameras, which is giving you basically the temperature, thermal infrared images that is related to the temperature of the object. Then LiDARs can be there, which gives you the height of the object. Then you can have multispectral cameras, you can have chemical detectors, you can have pollution sensors, you can have SAR sensors. But SAR is actually on a higher side. SAR sensors are there or for UAV, but the weight of the SAR sensors are few kilograms, and for that you require a large, big UAVs. So still now, a lot of still there is work going on to make it lightweight. SAR sensors are still on a very, very high weight categories, but the other thermal sensors, multispectral sensors, LiDAR sensors, they are in the range of few grams to kilograms, 1 to 2 kilograms maximum, but the SARs in around more than 20-25 kilograms of weight. So you can have different kind of SAR sensors, which UAV sensors like consumer grade cameras, multispectral, thermal cameras, hyperspectral cameras, temperature, pressure. So any kind of, depending on your application requirement, you can mount these sensors on board the UAV platform and collect the data. So this is, you see, traditional examples of the RGB, simple RGB cameras, the hyperspectral cameras. This is a thermal sensors, and this is a multispectral 5-band cameras, 6-band camera, which is there. Sorry. Now, multispectral sensors, there are two ways multispectral information can be collected on drone. If you want to go for a low-cost version of it, then you have a version called modified multispectral sensor. Basically, it is an lightweight RGB 3-band camera, but you apply a blue filter to it and collect the data in the near infrared band. So this is much low cost, and you have and very, very low weight sensor can be obtained. You can get it from the market at a low cost. Whereas with the multi-band spectral sensor, you have simultaneously, you can collect data in 5-band, 6-band, 10-band. So various versions of these multispectral cameras are available. So these are a few companies from where you can get these multispectral cameras with various range of wavelength ranges, which is there, which we can compare it with the satellite-based observations also. You can also get sensors which can directly give you an NDVI output from these acquired images. So this is a range of thermal sensors which is there available from different companies, which is operating in the wavelength region from 7.5 to 13.5 micrometers. Now, basically, this is the entire drone-based remote sensing hardware and software requirement which is there. You require a drone, the sensor which is there. It's a photographic sensor, simple RGB, whatever we just discussed. Then the success of any UAV campaign depends on the pre-flight planning. Where are the data you want to acquire? Which are the areas? What is the resolution? What altitude it will fly? All these planning has to be done. For that, every drone has a mission planner, right? And this makes it very, easier for you to operate the drone. So once you plan your mission properly before, then the entire process is very, very easy for data collection. So this mission planner allows you to plan the whole flight mission by selecting and defining the important parameters which is required to, get a successful results or data from the drone flights. So you need to understand these parameters which will help you in, getting good data sets from the drone platform. Right? Then if you want to georeference the data, because these data which is collected will not have the geographic coordinates, you can collect GPS on GPS data, that is ground control points, using GPS high-end DGPS equipment, and use this data to georeference the drone-based observations. Nowadays, some of the drones are also equipped with GPS, high-quality differential GPS on board it, which is, in that case, you do not need to collect GCPs on the ground. It gives you a direct georeferenced images from the direct collection itself. But then the weight and the cost of these drones are on a higher side, right? Then you need a powerful workstation to process these data sets and a software to process this data. Right? So you have entire UAV data collection and processing workflow where you need to plan and upload the flight planning parameters on the using the mission planning software, fly and capture the images, process and generate the outputs. Now, if you talk about, these are the few high resolution images which has been acquired using the drones. See the quality, and then they don't need to fly. Neither you can have any oblique angles also, as per you can fly as close as possible you want to fly. So you can acquire as per your requirement the images and then process these images to extract the various parameters like height, thematic information you can extract from this, the slope. So at a very detailed information can be extracted, right? So this was a simple RGB camera images which has been acquired using drones. Then this is the multispectral data using different wavelength region. If you can say near infrared, this is the red edge. This is the FCC of the high resolution drone images. This is thermal images which has been acquired during day and night. And during night time also flight can be, data can acquired during the night time. So different products which can be produced from the drone image, from the drone data acquisitions. Now, this is the flight planning which we said. You need to plan how the flight from here, the drone will take off from it till here, start data collecting, and then after this point, it will come back and land at this point again. So this is how this entire image was acquired with this small flight planning chip. Right? So this is a near infrared and the red edge band which was then taken, and the NDVI of the same area was generated. So this is the complete workflow of the data processing. You have a large number of images acquired, 300, 400 images even for a smaller area, because the resolution is so high, you have a good amount of images which is acquired. You need to align those images, use the GCPs to georeference, and then you can do a photogrammetric processing to generate a very, very high resolution digital elevation model, then generate an ortho image, and then use image processing to extract the various information which you want to extract. So you can do a 3D reconstruction, you can generate a bare earth information, and extract various thematic information from here, right? So this is the kind of product which we can produce. You have an ortho image, the relief map, 3D perspective view, thematic layers, and the elevation model. So this is one example. We'll start showing you very quickly few of the examples which we did here. So we have one of the study which we did in moderate terrain here, which has small hillocks plus agriculture to orchards to different range of land use which is there. Small built up areas were there. So fixed wing drone was used for this application. So we flew the drone at variable altitudes to see how much of the accuracy we can get in for the topographic or the terrain parameters. So in this case, there was a geological fault also, which was not seen on the original data sets, but once this information like the height information was extracted, and then we derived the bare earth model, so we could see the geological feature also very clearly from this data sets. So this is the bare earth model. So this elevation model is this one where height of the features is also there. Minus the height of the feature, one can generate the bare earth model. Then a contour of 1 meter interval could also be generated. A detailed slope map was generated. A topographic map of 1:2000 could be generated. See, if you can see the contours along the built-up areas, along the mango orchard, so different height levels of the mango tree itself, single mango tree could be captured, and the elevation information can be obtained here. So slope map of these areas were generated, and also a complete 3D picturesque view could be generated. We compared this data also with satellite-based observations. So if you see in the UAV data, a slope of 89 degrees maximum slope was achieved, which could not be seen in the Cartosat. In Cartosat, we could only get a slope maximum of 59 degrees. So certain areas or certain information would not be captured with, or it was, averaged out on a satellite-based platform. In a flat areas, Cartosat could only give a maximum 4 degree slope, whereas from the UAV, we could get an 8 degree variations. So this is an advantage with a drone platform. So this is another area where we tried the same kind of thing with variable altitude to get a kind of accuracies. So at GST, we flew at an altitude of 700 meters from the ground, so 23 centimeters. When we flew at 150 meters, we could get the spatial resolution of around 2 centimeters or so. So the UAV has a range of applications, we can say. It is used in variable applications ranging from, you can have a 2D maps. It can be used in cadastral applications. It can be used for, construction operations, which is there. So you have range of applications where drones can be effectively used. The data can be easily integrated into a GIS-based platform. And with the other layers, you can do a lot of analysis with this. Right? It can be used for land management studies. It gives you very high 3D observation for urban planning, infrastructure planning. Then asset management, forest fires, wildlife, counting of wildlife, emergency services in marine and coastal applications. And the major one, which is the disaster management. In all kinds of disasters, in all phases of disasters, one can use the drones very, very effectively. So we'll be talking about how drones play a significant role in the disaster management applications of disasters. So there are, as you know, different types of natural disasters, such as climatological, which is extreme temperatures, drought, wildfire, meteorological, like tropical storms, hurricanes, sandstorms, heavy rainfall, hydrological disasters, flash floods, debris, floods, geophysical disasters like earthquakes, tsunami, volcanoes, landslide, and avalanche. So when a disaster strikes, a rapid and effective response is required, which is very, very essential, critical requirement to assist the people there, to reduce the damage, both in terms of manpower, human lives, and the property itself, and mitigating the economic impact. So you can see from here that the UAVs have a significant importance or role in all phases of disasters. See it as a pre-disaster, during disaster, and post-disaster. So in pre-disaster, it's like prevention and early detection, during disaster, mitigation, monitoring, and relief and rescue operations, and in the post-disaster as a damage assessment and recovery. So regardless of the type of disasters or emergencies that occurred, but what is required is, it is a process of practice. Disaster management basically would require a practice or a process which will include mitigation, preparedness, response, and recovery. So here, drones have an important application or role to play. So why? Because what you need is an accurate data collection. And this time, many a times, as I said, satellite pass may not be there. Then the resolution of the satellite data is also a limitation. So and many times during disaster, extremely difficult conditions are there. So it's difficult to collect data on ground. So in order to get this kind of high resolution, high spatial resolution data sets, telecommunication also is affected in those scenarios. So drones also can help in those situations. So what they do is the drones helps in all these issues in disasters. They reduce the time required to locate the victims. When you can immediately fly, they give you photographs, pictures, so you can locate the victims. The time required for subsequent interventions by searching a larger area in a short period of time. Multiple drones can be employed. In addition to providing critical information to the rescuers about the routes that needs to be taken, it can provide you the routes that needs to be taken during search and rescue operations. They're also capable of searching live victims buried beneath rubbles using sensors. You can have special sensors on board it, such as noise sensing, binary sensing, vibration, heat sensing. That's what I said. You have the flexibility to mount any kind of sensors which is required for a particular operations. So in a nutshell, we can say that UAVs can be embedded into the entire life cycles of a disaster management. It can be used by the police departments to manage, fire brigades, disaster response departments, right? If they are equipped with the these small UAVs, they will be able to integrate these UAVs during the rescue operations, mitigations operations. So in a pre-disaster stage, UAVs can be used together with the existing early warning systems to accurately predict the outbreak and reduce the cost of the damage. Right? During the disasters, UAV can provide high-resolution, real-time images of even a very, very difficult situation or locations, which can be used to quickly produce a hazard map to guide the management, to assist or to make relief plans and conduct the rescue operations. And after the disasters, UAV can be used to map the affected areas in high resolution, because they will provide you high-resolution data in a short time. You can easily do a damage assessment, right? So drones, in a way, in a pre-disaster risk situation, they can do surveying, mapping, risk profiling, disaster risk mitigation, and disaster preparedness. So in all aspects of disasters, drones can play a significant role. So what is, as I said, real-time rapid processing, high temporal resolution, high spatial resolution, and it's an automated process. So quick data collection, quick data processing can be done. So where is there? You can have a change map if you want river erosion, deforestation, urban expansion. If you want to do a disaster risk management, in where is this can be used? Flood risk, disaster risk, volcanic eruption risk, where drone data can be easily collected. Disaster risk mitigation, map affected areas, that is damage assessment, broadcast, where communication is lost, drones can play a very good role in communication. Monitor forest fire spread, and accordingly remedial measures can be taken. In illegal activity like poaching, illegal fishing, illegal trade, drones can play a role in both in wildlife management. Then monitoring the mitigation patterns, agriculture like meteorological droughts, slow-moving landslide, volcanic monitoring volcanic craters, and slow-moving lava. So they have potential in all aspects of disasters. So one is like in urban flooding. UAV can provide high-resolution data for fast and accurate detection of inundated areas, especially in complex and urban environment. For geomorphological effects of flooding, again, you need very high-resolution elevation model, ortho images, so that you can study the riverbeds, floodplains, the amount of sedimentation which has happened, changes in the river carrying capacity, changes in the river courses, status of the river control structures. So all this can be accurately measured and mapped with the drone data sets. Forest surveillance, forest fire situations, building a fire risk maps, monitoring the vegetation, right? And monitoring for responses if there is a forest fire. Then damage assessment in flood. You can do a very good accurate damage assessment. Cyclones, floods and cyclones as a debris and saturated ground could be assessed very, very clearly. Whereas what earthquake, rapid information on collapsed building after an earthquake help to evacuate. Also to help in earthquake structural damages and early impact, because what is there? And an earthquake is a disaster which is actually without a pre-sign and causes very, very serious building damages and also to human life. So people may get trapped inside the building, right? So a rapid mapping of the affected area is very, very important, and assess the amount of damages. So in those cases, drones can give you a very good solution. Now in the pre-emergence phase, you can acquire high resolution data to analyze and interpret, that is the environmental characteristics and the potential triggering factors. You can derive from these data sets, and then you can have multi-temporal observation. Continuously you can observe at a location and then you can predict. So that one can do. In emergency phase, again, the high resolution data acquisition over the site for the assessment of damage, extent of damage. They provide you real-time, good, relevant information that is very, very specific and critical, required for even doing a rescue operations, and and also managing the entire scenario, providing aids to the people there, right? So landslides, again, use of drone for landslide studies and monitoring. It is one of the very, very important applications where drones also have a very high potential. When a landslide occurs, the first information which you need is to provide the extent of the area which is affected by the event. So the landslide impact extent is usually analyzed based on the high resolution DEM acquired after the event, and the digital elevation model, or which is there, that allows you to see the major changes which needs to be detected. That is the geomorphological features, has they changed there. So we'll show you an example how through modeling one can analyze the high resolution data acquired from a landslide and try to find out which are the areas which will be affected by landslides. So you can do a landslide recognition, classification, and post-event analysis, landslide monitoring, and susceptibility and hazard assessment. Right, so this is an example of a high resolution drone which has been image of a rock slide that occurred on a road. So this image was acquired after the rock slide occurred in 2014 in San Germano in Italy. So one can analyze the damage and the impact it will cause to the nearby areas. This is one example which we did. See, the state government of Uttarakhand, basically the district magistrate, they requested us. This is the Nainital area where this is the Balianala landslide zone. So they requested us to provide a very high resolution information so that they can take appropriate measures. Suppose if a landslide is triggered, which are the areas which will be affected, or to, take measures so that this landslide doesn't further get activated, stop this process. So we did a drone flying. What the flying which we did was in a very, very harsh condition. So if you see on this side, the condition when the data was acquired was totally foggy. It was in the month of July, August, when it was totally covered with cloud. So we flew at below the cloud level, and then we acquired this data sets. Right? And if you see, the quality of the image is not affected. So we could fly below the cloud level at a very close altitude near the object itself and acquired these images. So we acquired the images. The resolution of the photographs were around 1.18 centimeters, and the ortho images of 2 centimeters could be generated. So this is a complete 3D perspective of the landslide areas, where you can see the complete detail. If this landslide, we can map the slope, and if this landslide gets triggered, you can do an analysis from this, and the debris will flow. Which are the areas which will be impacted? One can do further studies on to use this data for those further analysis, right? And so this is how the flight planning was done. Flight missions for the data acquisitions. We could generate a 1 meter contour interval, a complete 3D perspective digital surface model where you can see a minute details of the landslide zone areas. So a detailed slope map and the contours of this area was generated and handed over to the agency for further action. They will be doing geotechnical surveys to, correct for this. So this is a very high resolution information which was collected here. So the roof terraces, small objects on the roof was also clearly visualized and mapped using this high resolution drone data sets. This is another example where this is an inactive landslide temporarily, but we did a simulation study here where drone data was acquired. Drone data was acquired along the direction of the slide itself. So we did it with a quadcopter rather than with the fixed wing drones, where a 20 centimeter digital elevation model was generated. Then using the flow model technique, where your model was used, where using this very, very high resolution slope information, or it was modeled to see if the landslide triggers, then at what rate, what will be the flow height and what will be the flow velocity of the debris which will flow from here, and which are the regions which will be impacted. So this kind of analysis, which we have very, very high resolution detailed slope map or height information, one can use these models to simulate the speed of the debris if it happens, the speed and the flow velocity, flow height and the velocity, and to the spread of the debris to which areas will be affected. So if it happens, one can take a remedial measures that these are the areas, and one can inform and take and save human lives and property in those cases. So drones can be effectively used for earthquake damage assessment. So this was used effectively in the Nepal earthquake, which occurred in 2015. So once it was a very severe earthquake, many private players came into there. We collected the drone data to assess the damage assessment of the buildings. So the main advantage, as I said, their availability and the ease at which they are repeatedly acquire high resolution areas, and also was used for the search and rescue operations in the region. This is one example where we did for one of the heritage, or you say cultural monument site in Myanmar. This is a Sulanamani temple in Bagan, Myanmar, which where a violent earthquake measuring 6.8 hit the central Myanmar in 2016, causing damage to the 14th century archaeological site of this city in Myanmar. So this is the ground photograph of the temple, where you can see this is the area which was highly destroyed by the earthquake, which was affected by the earthquake. Now, the advantage of drone as again compared to a satellite-based observation. Satellite post-event, the satellite data was there available, fortunately, in that area. But if you see another advantage, which I said was the observation geometry. Now, in this case, the damage happened on this side, and this side happened to be on the shadowed region. So on the satellite data, this data could not be collected. So where the damage was there, that was missed out on satellite observations. So when drone could be collected, data could be collected by flying along the build-up area or along the monument itself. So the damage and the debris visibility was restricted with the satellite observations, which was collected or possible from the UAV platform because it has a multi-directional viewing. So it can be. So it was mapped, or data was acquired through the UAV, and the damage debris assessment, how much is the debris, the volume of the debris could be mapped and estimated and mapped using the drone data sets. So the advantage is you can get the data both in shadowed and the non-shadowed. Damage assessment can be done in both the regions, right? And the estimation of the volume of the debris was as good as to 94 to 95%. In floods, again, these are the images captured in the Japan flood scenarios. So drones can be effective for both, again, search and rescue operations, for detection, for planning, and doing post effect corrections which are there. This is one other example. This is not from a drone, but using LiDARs on board drones, one can use the study. This is a small landslide zone here in Dehradun, where the built-up regions are there just below the landslide itself. So in these areas, we did it with a combination of the laser along with the ground range photographs, which can be done from the satellite-based platform itself. So what you require, TLS gives you a very, very high resolution digital elevation or the digital terrain model, which is required for these kind of studies. So on board the drone, even if you do not have LiDAR sensors, even with very, very high resolution, low level, what we did with the Nainital region, similar things can be acquired at a low altitude of 1 to 2 centimeter resolution, and very high resolution digital terrain model can be generated, and you can do the disaster loss estimation. That means by integrating, using this high resolution DEM, I can estimate if there is a debris flow, at what flow velocity it will, or what are the areas which will be damaged. So the loss due to the landslide can be simulated, you know which are the extent which will be affected, and accordingly the action can be taken. So if debris flow happens at what speed, at what time, volume, velocity, everything one can simulate and see which are the areas which will be impacted. So this study we had done with the TLS, but same, which what you need is a high resolution digital elevation model. So one can apply, and this is similar thing we did it for the Koti landslide, which I said we estimated the flow velocity and the flow height. So drones can also be effectively used for the forest fire detection and management. And not only that, they can be equipped with sensors where can tell you the mouth of the fires. They can also be equipped with the instrumentation for fire extinguishing. So you can have elements both ways. They can tell you exactly the mouth of the fire. They have thermal cameras you can place where they can see from the smoke plumes, inside the smoke plumes, and tell you where the mouth of the fire is. And accordingly, they can also be used for the extinguishing of the fires. Now, drones can also be effectively used for telecommunications purposes, bridging the communication. Right. So in case of disasters, you have, issues where sometimes because of certain disasters, in certain scenarios, you have complete network failures. You do not have communication. So UAVs can be used as a communication relays to, relay to bridge communication in those areas where part of communication infrastructure is destroyed due to earthquakes, floods, or any man-made disasters. So this is one example which shows you an architecture of a UAV-based cooperative wireless network which can be deployed over a large geographical area in order to provide an on-the-fly communication facilities in the disaster-affected areas. So UAVs can be exploited as an early warning system where they can be coupled with the wireless sensor networks to provide a comprehensive and high-efficient warning for disaster predictions. There are several mechanisms by which one can use UAVs with wireless sensor networks. One is UAVs can be regarded as a mobile-based stations or a data mules in the sky to provide the communication between the wireless sensor network and the decision-making center. The second scenario could be that UAV can be integrated to a wireless sensor-based early warning systems when a certain node or a part of the network architecture is completely failing. So UAV could be deployed as a relay node in the entire network to deliver data among the remote wireless sensor networks, nodes, which is placed there. So emergency communication is very, very important in case of disaster response and recovery. And the aim of emergency communication is to provide what? The communication for disaster rescuers, affected people, plan makers. And what you need is reliable and easy access communication system is a key for any, disaster management applications. So such as information gathering for search and rescue and disaster assessment. So many times this high-speed internet wireless cellular network, they get disrupted by these disasters, and drones can be effectively used in these scenarios. Many times multiple drones have become popular to form an ad hoc network to provide a wireless signal to a wide area coverage. So drones are very effectively used in disaster management. You have a swarm of UAVs. So swarm of or a fleet of UAV network vehicles is nothing but a set of drones that work together. They all synchronize together and work together to achieve a specific goal. So this is the ability of a drone to autonomously make decisions based on the shared information from one to the others. So you have a very important role of the, swarm drones in disaster scenarios. So they can easily reach the disaster struck locations that are dangerous and difficult to access. And they provide disaster estimation and facilitate inputting effective countermeasures. So, for example, if there is a case of wildfires, the swarm drones equipped with fire extinguishers or cameras or any other similar kind of equipments can quickly examine and handle a larger area without endangering human lives. So they can be made intelligent enough. In recent pandemics also, we have seen where drones have played a very significant role. In many countries, like one in Australia, they had cameras on board drones where these drones was used to, remotely monitor the temperature, heart and respiratory rate, as well as detecting the coughing and sneezing at a distance of 10 meters. They were all across India and other places, has been used for crowded areas such as airports and healthcare facilities. So this is how, from a remote distance, using artificial intelligence, thermal images, optical images, one can find out the anomalies here in the temperature. So wherever there are there, so one can easily detect those. To monitor the congregations and religious contamination, spraying of the during the pandemic, it was used for spraying the disinfectants there. They over large, as I said, spraying of sprayer drones are there. Even in agriculture industry, sprayer drones are there to spray the pesticides. So many countries have used drones as a disinfectant, and they have also used in food deliveries in inaccessible and remote areas, surveillance drones to monitor the crowd in the pandemic scenarios, and also for emergency medical delivery by drones, even collecting blood samples from a remote locations, bringing it to the laboratories where in remote areas these lab facilities are not there. So providing gloves, masks, sanitizers, other medical devices to the patients in remote areas. So drones have been effectively used in the drone scenario, which again, so drones, they provide you a very ultra high resolution data and a very high temporal resolution. So as and when you want the data, you can fly and collect the data. This data can be 5 centimeter or even 1 centimeter to that matter. Similarly, you get a digital elevation model, digital surface model, ortho images is there. Vertical accuracy is also 10 centimeter, and depending on the acquisition, how much is the spatial resolution. So the vertical accuracy can be 10 centimeter or even better there. They can fly at low altitudes in difficult terrain, ability to reach remote areas, acquire images with the quadcopters or with the multi-rotors. You can fly at any different angles, capability to mount the sensors as per your requirement. So these small UAVs are a very powerful tool for disaster risk assessment, monitoring and response and recovery operations, and they are also cost effective. So with this, I conclude, and I now invite few questions if there are from your end.